uh, with online, we have many problems to control the cheating situation, and this is my decision for, hopefully this is the last semester, online semester, hopefully, but I've decided to absolutely, you can use notes, books, open book, open note, but during exam, you're not allowed to use phone or look at your computer. You have to do it on a paper. At the end, you inform proctor, and then you use your phone to take a picture at the end, maybe the last 5 minutes at the end. Other than that, you cannot use it. But again, if you print your notes or books, I mean, not printing book, but if you have book, notes, and if you're looking at, like, for example, papers or something, we don't have any problem with that. I'll send you information and guideline by Thursday, because Thursday I want to finish everything. I have some idea about exam format and material and number of homeworks. So I can give you better information on Thursday. Again, exam is on next Tuesday. It takes the entire class time, plus I give you 10 minutes. So be prepared to attend. If you have other classes, please inform your other professor that maybe you're 5 minutes maximum late, because it may take a little bit time to, it's just like a Canvas submission. Like you have a certain time to submit, otherwise Canvas is not accepting your exam. It's the same thing, except that you're sending by email. I'll give you all that information later. Exam format is either multiple choice, problem solving, or combination, and I don't disclose the format until you see the format on the day of the exam. Okay, I have to start and finish chapter. I'm going way too slow for this class. Actually, this is the slowest that I've done. Usually by this time, we are in the middle of chapter 3. But for some reason, maybe because I did involve students in asking question and answering question, class participation. When it's online, it's very time consuming, but it's okay. I do take roll today. I don't know when, but my priority right now is to start. Pay attention to the lecture, because I know that some students, they don't listen, but then they ask question by email. I don't understand this part. I don't know. If you pay attention to the lecture, just like face-to-face, and you don't just log in and leave the room, you'll be much better off. It's much better than circuit analysis you learn by listening to somebody to explain the process. Usually it's difficult to learn topics or methods by Googling or, I don't know, reading on your own. It's much easier if somebody explains, maybe using one example, and then you can just read on your own after that. Okay, let me start, but do you have any general question at this point before I start? Maybe a quick question, because I have to use my time. Make sure to finish chapter 2, hopefully today, so I can do problems and practices. Maybe you can keep all your questions and problems until Thursday, have all the questions on Thursday, and then maybe we can wrap up. It's only 2 chapters, but these are 2 important, super important chapters, foundation of circuit analysis. Any question? Okay, so far we talked about circuit laws, KVL, KCL, Ohm's law, Telegin's law, energy law, Ohm's law, KVL, KCL, to solve circuit problem. But in order to solve circuit problems, we must apply 1, 2, 3, or all these, not all, but mainly KVL and KCL and Ohm's law. And you end up with many equations. You may end up with many equations. We are talking about large circuit and many unknowns. Okay, this is a time-consuming process. How can I get rid of many equations, many unknowns? The only way is to use shortcut methods. We can actually bypass some equations. You can bypass some equations or some formulas and make the calculation easier. So this bypassing is what we consider as shortcut method. You cannot just bypass arbitrarily or on your own. The bypass should be validated by KVL KCL. So any shortcut method I explain here is the result of KVL KCL. However, in order to make it easier for you to understand, to follow, or to implement, for me, implementation is important. I may not show you how I use KCL KVL. I just give you the result. Proof is not that difficult. Usually I sometimes, depending on time, sometimes I show the proof. But again, this time, for some reason, I'm a little bit behind. So I skip the proof. I just give you the results. So understand how to use it. And in order to understand, actually the method, the explanation is only, I don't know, few steps. And I have to show you by using examples. So the lecture from this point on until almost the end of the semester, it's all exam oriented. I don't have any definition, written definition here. I just put an example on the board and apply shortcut method and show you how to use the shortcut. And somebody asked me, I think a couple of you may be asking by email that is there any outsider, but you really don't need it. The Google, if you do the Google search and find other resources, there are plenty available. But sometimes they may confuse you more. And also doing many problems, you really don't need it. Just practice on few problems several times until you understand the concepts. Because notice that circuit is changing. Circuit is not just one general format, but there are some general guidelines that if you feel comfortable with them, then you'll be okay. So let's start the shortcut. And in order to start the shortcut, I'm going to focus on series circuit. It means that everything is connected in series. Or you reduce to series. It's a series circuit. So your final form is series. Okay, what you have in series circuit, you have independent sources. Combine them. Usually it's a voltage source. Then you have resistors. Or you may have a dependent source. So when you have a circuit, at this point, we have a combination of independent sources, dependent sources, resistors. So that's a series. I'm going to start with example one, when I have just a bunch of resistors and one independent source, and then I'll give you more example later. Here's the case. Let's assume that we have one voltage source, let's call it V input, and a bunch of resistors, R1, R2, R3. I did spend a great deal of time on series parallel, so now I'm not saying you're not allowed, but by now you should be okay with the concept. Okay, the current coming from the source, the direction, you can assign any direction, but the positive current, because current is delivering element, source is delivering element, it's better to assign the current from minus to plus. But if they give you any direction, fine. You just end up with negative sign. This current is passing through each resistor, dropping a voltage, and we use passive sign. So just move your hand. Anytime it hits the entrance of the resistor, put plus, leaving minus, plus, minus. And you label V1, V2, V3. Okay, questions about the circuit. If you stand across source terminal, like if you're standing here and looking into the circuit, what's the total resistance? Again, these are all based on KCL and KVL. In this case, it's KVL. It's based on KVL. You have to write, if you want to solve this equation, you write the KVL equation. So what's the KVL equation? V input equal to V1 plus V2 plus V3. Then you use Ohm's law substitute. So V input is equal to V1 plus V2 plus V3, and each one of them Ohm's law are, this current is I, R1I, R2I, and R3I. I'm not going to write even clearly because by now you should know it. We have done it. There is only one current passing through a series circuit. Each voltage is a resistance times I, resistance times I, resistance times I. Okay, if you factor and simplify, you come up with this conclusion. The total resistance is called R equivalent, seen across the terminal AB. Like when you look at it, it's a combination. Series is a summation. R1 plus R2 plus R3. You can add more. So notice that when you have resistors in series, the total resistance seen by the source is higher than any of them. What happens if you cut any of them? If any of them open, then the current stops. That's why in wiring system, household wiring, they don't connect appliances in series. Because if one of them malfunction or stop functioning, everything else stops functioning. The current goes to zero. So this is question 1 for series. Question number 2. What's the total current coming from the source? Total current coming from the source I. It's equal to the total voltage V input divided by the total resistance or equivalent. So the source voltage V input divided by R1 plus R2 plus so on and so forth. I mean, in this case, R3, R4. As long as many series resistors as you have, it gives you total current. You don't have to write any detailed KVA. Notice that I'm bypassing writing KVA. And number 3, what's the voltage across each resistor? We are using a method called voltage division. It's a combination of KVL and Ohm's law again. It's a Ohm's law. I have take total current, multiply by R1, you find V1, multiply by R2, you find V2, so on and so forth. But the result is any voltage across any resistor, let's say V1, it's equal to the resistance of that V1 divided by total resistance multiplied by input voltage. As simple as that. So if you have V3, for example, it's R3 over total multiplied by input. You're dividing voltage in 2 portions. Each portion depends on the corresponding resistance. However, one thing you have to do at the end, anytime they ask you to find the voltage across each resistor, make sure that passive sign convention is satisfied. Otherwise, you have to put a minus sign. Meaning what? Once you write the formula, for example, for V1, go back and follow the direction through V1. Current through V1 should go from plus to minus. If the current coming from the source goes from minus to plus, then you just have to put the minus sign here. I'll give you a numerical example in a moment. So this is shortcut for series circuit. If you don't have any question, I appreciate if you mute your mic. So this is the general guideline for series circuit. I'll give you 2 examples. And the second example, I'll give you 2 examples from the book, and then you can ask question and we can move on. Let's assume that we have plus or minus 10 volts, 6 ohm, plus or minus 4 volts, 10 ohm, I don't know, minus plus 2 volts, okay, 8 ohm. Suppose the question is find voltage V output, find total current I, and find, okay, let's just keep V output. Okay, in this case, I have 3 independent sources. You can simplify as 1, but you have to choose a reference. Let's assume that you choose a reference source. Make a selection. Let's say 10 volt is your reference. Remember, I showed you the guideline, whatever reference source is yours, go to that location, redraw. However, use direction, clockwise, for example. And then, as soon as you start with the source, the voltage pattern is your base. It's a voltage rise. So rise is plus 10, drop minus 4, rise plus 2. So you have 12 minus 4 equal to 8 volts. So you just adjust it at 8 volts. Then you draw everything else, 10 ohm and 8 ohm, minus plus V0. This is now reduced to a single loop. So what's the direction of positive current, I? What is our equivalent seen by the source summation? 6 plus 10 plus 8 is equal to 24 ohm. That's the total resistance. What's the total current, I? It's 8 volt divided by 24 ohm. So it's equal to 1/3 amp. So this is your final total current. But the question here is V0. V0, it's 8 ohm because V0 is associated to 8 divided by total resistance 24 times the total voltage 8 volt. Ohm, ohm, 8 volts. However, pay attention to the current. The current coming from the source, is moving in this direction. So it hits 8 ohm. Pay attention, this polarity is given by the problem. The current I goes through V0 from minus to plus. It's non-passive sign. So you have to put a minus in front. So the value of V0 is minus because polarity is opposite the direction of the current. Okay, so it's equal to minus 8/3 volts. Look at the amount of work. Instead of writing KVL equation, Ohm's law, this is the result of KVL Ohm. But you can bypass most of them and just in few steps find 3 important information about the circuit. The total current circulation, voltage division by having the voltage, this is called voltage division law, and the total resistance. Any question here?
Question, Professor.
Yeah.
If we get a positive answer, oh, you just went over that. I'm sorry, and we would see that by the passive sign convention.
Yes, yes. At the end, always check it at the end. Once you finish everything, because passive or non-passive doesn't change the formula, except that the minus or plus sign. So once you write your formula at the end, just look at the direction of the current, move along the circuit. If the current goes from plus to minus over the resistor, it's plus. If it goes from minus to plus, then it's minus. So all you have to do is just put the minus in front. Any other question? If they ask you how much power is absorbed by the resistor, P8 ohm, you don't have to find, you can either use current or voltage, doesn't matter. Remember, we have power associated to resistor, we have 3 formulas. We have voltage times current, we have voltage squared divided by resistance, we have current squared times resistance. A resistor is always absorbing, so you don't even have to worry about passive sign, non-passive sign, minus sign, plus sign, doesn't matter. You just take the value. For example, if you use V squared divided by R, remember minus a square is plus anyway. So it's 8/3 the square divided by 8 ohm watts. Or you can use current. Remember, current is 1/3. So it's 8 ohm multiplied by 1/3 square. So both cases you can use to define power. I give you another example. Okay, I'm going to keep the same circuit. This was a good time to involve students. But again, as I said, because I'm a little bit, I notice when I compare my lecture with previous year, I'm a little bit behind this year. So I try to do it myself. And then when I catch up, then I can involve a student. Okay, this is example 2 actually. This is a different example. What I'm going to do, I'll take away this source, one of them. Because many students, they're terrified by dependent source. And I substitute by a dependent source. And I'm going to call it plus or minus, I don't know, 2 V1. This is a dependent source. It can be a dependent on current or voltage, doesn't matter. Question is still, what is V0? Okay. Anytime you have a combination of independent or dependent source, you're allowed to combine them. However, my advice is don't combine dependent source. Leave it alone. Just combine independent sources as one. 10 volt rise, 4 volt drop. So I can simplify these two as one, substitute by 6 volts. 10 volt minus 4 equal to 6. Keep the rest of the circuit the same. However, in this case, I have a problem because my dependent source depends on 2V1. V1 should be given someplace. So let's say this is V1. Otherwise, you cannot solve it. This is given by the problem. When you have a dependent source, that controlling element or controlling quantity should be given. This is V1. 6 ohm, 10 ohm. Okay. Anytime you have dependent source, you're better off just to write direct KVL. Again, you can use voltage division, but students, especially at this point, they get confused. So my recommendation is, with the dependent source, just write KVL. Remember, in this case, you cannot define R equivalent because of the dependent source. How do you know what is inside dependent source? Dependent source is not physical source. It's a model. So it's better that you just write a KVL here. Okay, so it's the voltage rise. Let's practice KVL plus, minus, plus, minus, plus, minus, minus, plus. Just use as it is and write KVL equation. So you have 6 volt rise, drop, 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 rise, plus V0 equal to, okay, this voltage directly substitute Ohm's law, 6I plus 10I plus 2V1, 6 volt minus, because you're using voltage, this is voltage drop, 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 rise, rise. 6 plus V0 equal to 6 times I, 10 times I, plus 2V1. Now you have several unknowns here. You have the option of substituting all of them in terms of V0, in terms of V1, or in terms of I. I is the common current. Let's substitute everything in terms of I. Okay, V0 is minus 8I because current goes this direction. V1 is equal to 10I. V1 is equal to 10I. Okay, so back to this equation. I have 6 minus 8I equal to 6I plus 10I plus 2 times 10I. You have I simplify, so you get 6 equal to, taking I to the other side, you have 20 plus 10 is 30, 36, 36 plus 8 is 44. So from here, I is equal to 6 over 44 or 3 over 22 amp. Once you find I, you can find everything else. The problem is asking about V0. V0 is equal to minus 8 times 3 over 22 amp, and you find it. My point here is the dependent source is not causing any problem, except anytime you have a dependent source, maybe it's better to go back and just write the KVL equation. If you have all independent sources, use the shortcut, voltage division. But if you have a dependent source, simplify your independent sources as one leave the dependent source, and just write the KVL equation. And because of the dependency, you may need to do extra work. For example, in this case, it depends on V1. So separately, you have to relate V1. And always, when you have a series circuit, it's better to have your equation in terms of the common variable. The common variable in this case is I. So express everything in terms of I. Any question here? Instead of doing 10 problems, if you still have struggling with the concept, take this example and do it several times until you feel comfortable with the concept.
Question, Professor? Just,
Yes.
Even if it's a dependent current source,
Yeah.
it would still make it difficult to use voltage addition?
Let me say, for example, let's say, in this case, because it's a series circuit, if it's a dependent current source, I mean, if it's a dependent voltage source, but depending on current, is that your question?
I mean, that's another circumstance, but my question was just in case if that was a dependent, like current, dependent current instead of what that is, which is voltage. If would it still make it hard to use voltage?
No, because it's I don't see it. Let me just see. So you say this is a circuit, okay? Because it's much easier if you tell me what happens according to the circuit. So I keep the voltage source, resistor, 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 and this dependent source, instead of 2V1, it's 2I. If that's the case.
Yeah, so that would that just I mean it'll change up the system of equations, I guess, but I don't know if it would make it hard to use.
Because in this case we only have one current, it's going to be, let's say, 2I, and I is this current, okay? No change in KVL because it's a voltage source. So you still have 6 volts, 6 volts equal to plus V0 equal to 6I plus 10I plus 2I. Okay, so now you just need to substitute V0, where V0 is equal to minus 8I. The dependency quantity can be either voltage or current. If you change it from voltage to current or current to voltage, it doesn't have. See, KVL, KCL depends on your dependent source being a voltage source or a current source. If it's a voltage source, the KVL format doesn't change. The dependency variable, that will change your additional equation, because previously we had V1, I had to define V1. In this case, I have 2I. I don't have to define, like, it's 2I and I is the common current. So yes, the dependency variable may change your follow-up calculation, but it doesn't change your overall KVL equation.
Thank you.
Any question? Please collect your questions also for, I'm trying to, hopefully I'll finish. Okay, next shortcut. This is shortcut number 1. Shortcut number 2. Suppose we have a parallel circuit. What is a look of parallel circuit? You have everything in parallel. Okay, so you have a bunch of resistors. And mostly, you can have anything. Mostly you have a current sources. Dependent or independent. Let me start with a simple case. So let's say we have a current source and 2 resistors, R1 and R2. R1 and R2. So you have voltage, instead of voltage source, now you have a current source and R1 and R2. Okay, in this case, we have only one voltage. Remember, for parallel combination, we have only one voltage, which is the voltage across all of them. This current I is given. Then we have branch currents I1 and I2. The current I arriving at this node is divided into 2 parts. And also the total resistance seen by the source. Again, KCL. plays role here. You have to write a KCL equation. According KCL, I is equal to I1 plus I2. I1 is equal to V divided by R1. I2 is equal to the same V divided by R2, and you simplify. This is the detailed process. You write KCL and Ohm's law. You can bypass actually the result. Anytime you have parallel resistors, total resistor, it's 1 over R equivalent equal to 1 over R1 plus 1 over R2 plus as many as you want. Or you can use conductance. Conductance equivalent is conductance 1 plus conductance 2. So for series, you add resistors. For parallel, you add conductance values. So this is the way you find total. Many students, when they use this format, at the end, they forget to find the inverse. Notice that 1 over R1 plus 1 over R2, you can have as many as possible. 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. It's 1 over R equivalent. So what is R equivalent? 1 over the number that you get at the end, inverse. You must invert it. Okay, if you have 2 only, then you can use this formula. R equivalent is equal to R1, R2 divided by R1 plus R2. Only 2. So if you're comfortable this way, you can pair them. So you can pair. Like if you have 4 resistors, pair any order. You can pair 1 and 4, find a result. 2 and 3, find a result. And then you pair 2 results. You can only apply this formula to 2 parallel resistors at a time. If you want to use them simultaneously, then you have to use this one. Okay, so this is how you simplify or how you find the total resistance, total or equivalent resistance. Then once you find the total resistance or equivalent resistance, what's the total voltage across parallel combination? That's Ohm's law. Notice that equivalent resistance means that the total resistive effect, this is R equivalent. So you have R equivalent, you have total current. So what is total voltage across parallel? It's total current times R equivalent. So if they ask you how much voltage is across parallel combination, parallel combined resistors all in parallel, multiply by total current, that gives you the total voltage. Now branch current, this is, once you find total voltage, each branch current is total voltage divided Ohm's law, divided by the corresponding resistors, V divided by R1, V divided by R2. However, we can also simplify and give you the shortcut. The shortcut is called current division law. Okay, current division law, I give you 2 scenarios. Please pay attention. I give you 2 scenarios for current division. Pay attention to both and use them depending on the way you like to use them. I'll give you a numerical example in a moment, but I want to give you in general, and then I'll give you a numerical example. Okay, scenario 1. Let's say you have a current source. They don't even have to show you current source. It's very common. They say that the circuit is connected to something, and this is a total current coming from this side. And then we have a bunch of parallel resistors, R1, R2, R3, go on and on and on, R4. You can have many of them. Then you have I1, I2, I3, so on and so forth. Branch current. Okay, let's say I1. Remember, for voltage, we have the same resistance. In this case, if you want, you have 2 options. Option number 1. combine the rest, R2 in parallel with R3 in parallel with R4. By the way, parallel combination, it's denoted by R in parallel with R1 in parallel with R2, R4. Except R1, combine all of them in parallel, put in the numerator, divided by R equivalent times total current. I'll give you a numerical example. So it's other resistance divided by total times I. That's a branch current. Or you can copy the same format as your voltage division. Branch current is equal to the same conductance G1 divided by G1 plus G2 plus G3. Same as series. Remember R1 divided by R1 times R. You have two options. You can either use conductance option or you can use resistance option. This is called current division law. I have to give you a numerical example in order for you to understand the situation. I'll do it both cases. Yes, go ahead.
For the first one, those parallel ones, is that supposed to be a summation?
Parallel means parallel, 1 over. What is the parallel combination?
Yeah, but the numerator, the expression right there, R2 parallel R3 or parallel R4.
R2 in parallel to R3 in parallel to R4 is not a summation. It's 1 over R equal to 1 over R2 plus 1 over R3 plus 1 over R4 and then inverse. Parallel combination, not summation, parallel. Only for conductance. G1 divided. I'll give you a numerical example in a moment. Like you have to see it numerically. Okay, let's do a numerical problem. Suppose we have 10 amp. And yes, let's use 6 ohm here, 2 ohm here, 12 ohm here. I want to practice current division first. Okay. Question is find I2. Option number 1. Okay. For option number 1, you have to reduce circuit to 2 resistors. So you keep it as 10 amp. Question is about 2 ohm. Don't touch it. Combine these two in parallel. What is 6 in parallel with 12? You have two options. 1 over 6 equal 1 over 6 plus 1 over 12 equal to 12. 3. This is equal to parallel combination. 1 over R. The inverse R is equal to 12 over 3 equal to 4. However, because you have only 2, you can also use 6 times 12, 6 plus 12. This is equal to 4 ohm. That's a parallel combination. There is nothing I can say more than this. Practice. You do need parallel. For this class, you need parallel if you're EE. If you need parallel if you want to take EIT exam, you need parallel for exam 1, exam 2, exam 3. I don't know how to help you more than this. There are formulas. You either use inverse summation and then inverse at the end, or you can compare them as 2 at a time. 6 times 12 divided by 6 plus 12 equal to 4 ohm. So these two, they are combined as 4 ohm. Location is not important. So we combine 6 and 12 as 4 ohm. We leave 2 ohm alone. And then this is a question I2. This is 2 ohm. Now I2 is equal to the other resistance 4 divided by 4 plus 2 times 10 amp. You have to reduce to 2 other resistance. This is current division law. So I2 is not R2. I2 is the other resistance divided by summation times 10 amp. This is option number 1. Option number 2, you don't combine anything. You just take the direct circuit. Okay. I2 is equal to conductance of the branch associated to I2, which is 1/2 divided by the summation of the conductances, 1 over 6 plus 1/2 plus 1 over 12 times the total current. Well, this is like a fraction. You have to simplify it. But you have two options. You either have combining other resistors, reducing to 2, using other resistance, then you don't have to deal with fractional form, or you can use conductance. Same conductance divided by the summation times 10 amp. That's a branch current.
Professor,
This is current division law. Yes.
on the top right where you did the 6 parallel 12, you can only do that when it's a pair, you said?
Pair. Only 2 at a time.
Okay.
You can only apply this when you have only 2 resistors in pair. Not only 2 resistors, you pair them. You can only apply to 2 at a time.
What if you had like 5? Could you pair
You
2?
can pair, yeah, you can do it this way. Let's say if you have, let me erase. I don't want any other question here. I'll show you. I don't want to move away from this page unless if there is a question here. Okay, before I answer your question like 5, what about the total voltage? They ask you to find parallel voltage, plus or minus V. That V, they can place it here, here, in the middle, doesn't matter. Then you can combine all of them in parallel. Suppose they don't ask about branch current, they only ask about voltage. Then you have to combine all 3 resistors. Okay, here comes 5, 6, 10. In this case, 3, you have 2 options. How do you combine parallel resistors? Again, you can do it simultaneous or 2 at a time. I'll show you both. Okay, in order to find R equivalent, I have 2 options. Option number 1, 1 over R equivalent, R total is equal to 1 over 6 plus 1 over 2 plus 1 over 12, meaning what? Total conduct. In parallel, total conductance is a summation of conductances. So you take common denominator, 12. So it's 2 plus 6 plus 1. It's equal to 9 over 12. You can simplify with 3 over 4. But this is not R equivalent. R equivalent is 1 over, upside down, 4 over 3. Don't forget to do that at the end. Many students, they just leave it as 3. This is not ohm, this is Siemens. It's Siemens, Siemens, Siemens. It's a conductance. Then it's 1 over that equal to R equivalent. This is one-shot method. If you want to use R directly, pair them. So this is a second method. You can pair them. Pair any 2 of them, any 2. But you have to do 2 at a time. So for example, you combine 6 and 12 first. Doesn't matter, you can combine 2 and 12 first. Take the result, combine again. I'm going to combine 6 and 12. 6 in parallel with 12. Now I can use the formula. Okay, so this is equal to 4 ohm. Then I take 4 ohm in parallel with the leftover 2 ohm. So it's equal to 4 over 3. If I have 5, then take the result. Like suppose you have 1, 2, 3, 4, 5. Any order, you can combine these 2, you can combine these 2, take a result here, take a result here, combine, and take the result, combine with this 2 at a time. Once you find R equivalent, total voltage V is equal to 10 amp multiplied by R equivalent. That gives you the total voltage. So you can find branch current through each one of them. You can find total voltage. You can find total resistance for parallel combination. Notice that if they give you this problem, and instead of I2, they ask you what is I2 in this direction, you can still use current division law. Find I2. However, always check at the end. If the current coming from the source supposed to go down, if the question is about the current going up, Then you do your current division, no change, except you put a minus sign in front. The voltage should always match the passive sign. The current should always match the natural direction of the current coming from the source. If it doesn't match, if it's opposite, you just put the minus sign in front. So for parallel combination, again, this is a problem. I can't say anything else. That's it. You find branch current, you find parallel resistance, you find total voltage. Now you can have 5, 6, 10, doesn't matter. I mentioned one little thing, and then I'll finish this part. Okay. Anytime you have resistors in series, total is always higher than any of them, because you're adding. R is equal to R1 plus R2 plus. When you have in parallel, total is less than any of them. Like for example, if you have 10 ohm, 4 ohm, 6 ohm, or combination is less than the lowest one. So by parallel combination, you're reducing total effect. By series combination, you're adding total effect. In series, if you cut any of them, if open, like this resistor opens, the whole current goes to 0. In parallel, if you open up any of them, you still have a current flow. That's why in wiring system, they put devices, they connect devices in household wiring. They connect devices in parallel. Because if you have any problem with any equipment, any device, the current through the others, they may increase, but they still function. In parallel combination, suppose you have a parallel combination. If you want, this is the network, it's connected to the network. If you want to make the whole thing disabled, just connect by a short circuit. Suppose you're in the lab and you have your network connected to, let's say, 2 ohm, 4 ohm, 6 ohm, so on and so forth. If you don't want 2 ohm, 4 ohm, 6 ohm part of your circuit, you want the current coming out directly go to ground. You don't want to get divided into branches. You just want to make them disabled completely. Take a short circuit and connect in parallel. Remember, these are resistance values. Resistance means they're resisting. This is a perfect pathway. So the current goes through the pathway to ground. The current completely bypasses 246. So anytime you want to bypass any combination of resistors in any format, you just take a short circuit wire and connect in parallel with the portion of the circuit that you want to bypass. So for series, I give you one last example, and then this is the concept example. Suppose we have a voltage source, 10 volts. We have a 2 ohm here, 4 ohm here, 12 ohm here. This is not series or parallel circuit. It's a combination. Part of it is series, part of it is parallel. This is a question. Find I0 using voltage division. Shortcut. I don't want you to write KVL, KCL. If you want to write KVL, KCL, you end up with 3 equations, 3 unknowns. I don't want to do that. Using voltage division. Find I0 using current division. Okay. As soon as they mention voltage division, you must have series circuit. As soon as somebody mentioned about current division, you must have parallel circuit. In this case, we have combination. So here is the way that you handle. For case 1 voltage division, I have to make it like a series circuit. But how? I can combine 4 and 12 in parallel. By combining 4 and 12, I lose track with the current. But notice that the parallel voltage remains the same. Let's call this parallel voltage V0. That's okay. I can combine 4 in parallel with 12. Because it's 2, I can use the formula. 4 plus 12. It's equal to 3 ohm. Okay. After that, you don't need to redraw, but maybe at the beginning, just to get the feeling of what's going on, you can simplify. It's 10 volt, 2 ohm. Notice that you lose track with I0, but you still have V0. And this is 3 ohm. Now you can use voltage division. Find V0. V0 is equal to 3 ohm divided by 2 plus 3 times 10 volt. It's equal to 30 divided by 5. It's equal to 6 volts. I combine 4 and 12 as 1, found voltage by using voltage division. Okay, once you find V0, go back to original circuit. Where is V0? Here. What's the question? I0. I0 is the current passing through 4 ohm, Ohm's law. So what is I0? I0 is equal to V0 divided by 4. 6 volt divided by 4. 1.5 amp. Look at, there is no equations and unknowns. 2 simple steps, you could find I0. Now, if you try KVL, KCL, write KVL for this loop, write KVL for this loop, write KCL for this node, you end up, if you don't know this shortcut, then you have to assign voltage current pair to each element, write KVL, KCL, you end up with 3 equations, 3 unknown. This is voltage division. I mean, so the point here is, as long as you have source, single source, voltage division, it's important that you be able to reduce sources to 1. If you have a dependent source, then you probably have to write KVL, KCL. If you have multiple sources, like for example, if I place a voltage source here, don't change anything here. Let's say if I place a voltage source here, then I cannot use voltage division. I have to wait until future chapters. But if I can reduce my circuit to 1 source and a bunch of resistors in series, I can use voltage division, take advantage of that. What about current division? Okay, current division, I keep parallel for current division. I want to use current division. For current division, I have to find this current, total current, because I have 2 parallel branches. I have to find total I first. What is total I? Total I is equal to 10 volt divided by total resistance seen by 10 volt. What is total resistance seen by 10 volt? It's 4 in parallel with 12. You go to the end, combine them in parallel. In series with 2. Combine these 2 in parallel, 3 ohm in series with 2. That's your total resistance. So it's equal to 3 plus 2 equal to 5 ohm. So what is I? 10 divided by 5 ohm equal to 2 amp. That's the total current coming from source. Now you have total current. coming from the source to parallel branch of 4 and 12. What's the total current? 2 amp. 2 parallel branches. The question is about I0. Current division, I0, because you have 2. You don't have to use conductance, use resistance. What is I0? Other resistance, 12, divided by 4 plus 12 times 2 amp. And simplify. You end up with 1.5 amp. Okay, to practice voltage division, current division, before you do any homework problem, see, I'm oversimplifying problems here because usually in circuit analysis, the way they teach this class is they just show you the concept, they define what is voltage division, current division, and they jump to super complicated problems. Like not super complicated, but large, much larger circuit. I'm not going to give you a huge circuit in the exam anyway. It's very similar to what I'm doing in class. Because for me, it's important that you feel comfortable with the concept. I have 2 methods. We have to bypass KVL, KCL. Otherwise, when you have multiple circuits or multiple loops, you end up with many equations, many unknowns. That's why you need to really feel comfortable. So use this example as your base to practice more on KVL, on voltage division, current division, series and parallel. Any question here? The last part that I want to mention, and again, I'll spend entire Thursday lecture on doing problems and answering questions. The last part, okay, let me give you one example. Let's say we have 2 ohm, 4 ohm, 6 ohm, 3 ohm. I can go on and on and on. Let's say 12 ohm, so on and so forth. Okay, you have several resistors connected. Usually they specify a terminal AB, and they ask you to find R equivalent seen across terminal AB. Usually you go to the end of the circuit, and you start from the end and keep combining. Starting from the end, do it one at a time, 12 in parallel with 3. So it's 12 times 3 divided by 12 plus 3. So it's equal to 12 over 5 ohm. Okay. Don't redraw, don't try from the beginning. Just visualize. You combine these 2, you find it. The result is in series. So you have 6 plus 12 over 5. It's 42 divided by 5 ohm. Or if you have a calculator, I don't have a calculator near me. Then you have, when you combine these 2 in parallel in series, combination is in parallel with 4. So it's going to be 4 in parallel with 42 over 5. So it's 4 times 42 over 5 divided by 4 plus 42 over 5. Then you find it. Then this result is in series with 2 ohms. So your R equivalent is equal to 2 ohm plus this result. So you always start from the end and you move toward the terminal by combining series, parallel, series, but you must be able to identify them as in parallel or series. Parallel means same terminal. Series is simple node in the middle. That's essential work. However, in power area, any question here? However, in power area, the wiring system and distribution system is based on three-phase. Okay, in order to understand three-phase in future, they connect three-phase either in this format, which is called the Y format, or this format, which is called delta format. This is three-phase, phase 1, phase 2, phase 3. Either Y or delta. I don't want to get into three-phase. I may not even have time to cover it. But in order to prepare you, what about if I have a resistor here that is connected in this form? By the way, they can pull this point up and make it like this shape. This is called Y shape. Okay, what is the point of, what defines Y shape? They are connected to different lines. So these are not connected in series or parallel. Notice that RA, RB, they have different terminals. They are not connected in parallel, obviously. They are not connected in series either, because current coming from RA is divided into two parts. So they are three resistors that they are connected in Y shape, but they are not in series or parallel. The other format that you may have problem combining is this format. Okay, again, three lines. You can extend the line and make it like this format, T shape. Or upside down. This is called delta shape. Again, these resistors, they are not connected in series or parallel. However, if you convert one of them to another one, this one to this one, you may be able to combine with the rest of the circuit. So this is called the conversion of resistors from delta to Y or Y to delta. And you need to know it's a formula base, and I'll show you the format and you learn how to do it. You may not use it in this course for in follow-up chapters, but if you have to take Power 1. And even if you're a mechanical engineering student, they do ask question in EIT exam, a conversion of Y delta, because this is the commercial power wiring system. Let me show you how to make the conversion. So this is the conversion aspect. What I'm going to do, okay, I'm going to define Y shape. And I'm going to assign node, I'm going to label node A, B, and node C. Okay, I'm going to call it RA, RB, RC. Then I'm going to connect A to B, B to C, and A to C using different color. I'm going to call it RAB, RAC, RBC. And there is a point in the middle. Anytime delta is given, go to the center of delta, put a node, and connect that center to ABC, and then find RABC. Anytime RABC given, connect the boundaries, and then just keep the boundaries, the border, delete the middle one. Then you have a conversion from delta to Y. So you can go from delta to Y, or you can go from Y to delta based on simple formula. If you have Y, and I show you, I give you example next time on Thursday. Thursday is my example day. If you want to convert Y to delta, it means that Y is given, RA, RB, RC given, find RAB, RAC, RBC. That's Y to delta conversion. Okay. Here is the formula. RAB, you don't have to memorize, but there is a nice pattern, is equal to, you multiply the two, RA/RB plus RA/RC plus RB/RC. Notice that RAB, RC, letter C is missing, divided by RC. RAC, same numerator, RA times RB, RA times RC, RB times RC, divided, B is missing, RB. RBC, same numerator, divided by RA. Okay, once you find RAB, RAC, RBC, then you go and delete the Y shape and you just keep the delta shape. What about if you have delta to Y connection? It means that RAB, RBC, RAC given, find RA, RB, RC. I sent you some example problems. In this case, again, it's a formula. So delta format is given, you want to find the Y format. RA is given. Okay, look at RA. Two side resistors multiply. RAB times RAC. Two sides, RAB times RAC for RA. RAB times RAC divided by the summation of everything, RAB plus RAC plus RBC. Then what about RB? B point, two sides, RAB multiplied by RA, RBC. Multiply two sides, divided by the denominator, same denominator, summation of everything. RC, two sides, divided by the denominator. Okay? That's a formula.
And this only works if we have if we're giving all the resistors, right? We have to have
Yes, yes.
Okay, cool.
Let me give you one example. Okay, let me give you one example. This example is from the book, from my own handouts. Okay, and I think I have time to do that, yes. Consider example. This, if you don't have time to even write it, that's okay because it's in the handout. Let's say we have 5 ohm here. Okay. I want to find R equivalent. This is 5, 4, 6, 10, 8, and 7. Nothing is parallel or series. Nothing. 6 and 7 are not in series because they have a branch in the middle. They are not in parallel. 10, 8. So how do you simplify? You have several options. Usually for Y delta, you have multiple options. In power, you only have one option. They always ask you to change delta to Y or Y to delta. You have multiple options. At this point, you cannot do anything. Either go and identify a delta shape. Okay, I have a delta shape here. I have a delta shape here. Or identify Y shape. 4, 10, 8 is Y. 6, 10, 7 is Y. Do one at a time. Don't do 5 conversions simultaneously. Just whatever you feel comfortable. I think most of us probably see this one as a good delta shape. Convert it to Y. How do you convert it to Y? put a node in the middle, connect here, here, and here. Let's call it, I don't know, R1, R2, R3. And later I'm going to delete it. So this is delta, put a node in the middle within this triangle, and then connect from each node to the connecting point, the tip of the triangle, and call it R1, R2, R3. And now let's find it. R1 equal to, this is delta to Y. R1 is equal to the side resistance divided by total going around. R2 is equal to R2, where is R2? Here, side 4, this is 4. 4 times 10 divided by the same, 4 plus 6 plus 10, the whole thing, the whole border. R3 equal to 6 times 10 divided by the whole border. Simplify, you get number. Once you get a number, redraw. Okay, how do you redraw? You put 5 here, and then delete 4, 6, and 10. And you substitute by R1, R2, R3. Just delete 10. There's no 10 anymore. Then after R2, I have 8. After R3, I have 7. And that's it. So you find R1, R2, R3. This is your delta. I mean, this is Y form, substituting for delta. It's R1, R2, and R3. There is no 10, there is no 4, there is no 6. You just erase it. Okay, now you can see combination. R2 is in series with 8. R3 is in series with 7. Then combination of R2 plus 8, find the number. I mean, I don't have calculator number, but you keep on. It's in parallel with R3 plus 7. Okay, find it. Then this combination, this is in parallel with this one. This combination is in series with R1. Find it. And then the whole combination is in series with 5. Now you can reduce this original messy looking combination to just one resistor. After going from delta to Y, notice that I could back to back simplify. R3 is in series with 8, R3 in series with 7. This combination is in parallel with this combination. Then the result is in series with R1 in series with 5. Again, take this example, do it instead of looking 10 examples, take this example and do it 10 times. That's always my advice for learning, for good understanding of circuit concept. Sorry, if you have any question, I still have a little bit. Take this for this example. There is one special case that is very important in practical when you're in the lab, but I have to mention maybe about 5 or 10 minutes about this example at the beginning of Thursday, but I probably have plenty of time to do problems. I'm going to send maybe additional solution about this delta Y, maybe 1 or 2 problems. That's all you need. And you also have homework problem to practice voltage division, current division, and combining resistors. By the way, in any time in the problem, any problem, let me just mention in any problem, I didn't take all, that's okay. If they ask you to kill independent sources, this is a simple concept. Kill means not operating. If you have a voltage source, if you kill, it's a short circuit. It doesn't provide. If it's a current source, when you kill, it's open, not providing current. So remember this term. I think I mentioned it in chapter 1, but I want to mention again. When you kill a source, you cannot kill dependent, but you can kill independent. When you kill independent source, that's a terminology they use in the lab. They come and say, okay, in your circuit board, kill the voltage source. It means turn it off. When you kill the voltage source, it means 0 voltage, short circuit. Kill the current source, open circuit, 0. Just become familiar. We only have about 5 minutes, maybe lecture left, maybe 5 to 10 minutes. And then after that, on Thursday, I go over problems, questions, everything. If you have any question, please ask. Otherwise, have a good day.
Professor?
Yeah.
Are you gonna like send like any kind of review sheet or anything like that?
No, there's no review sheet because my handout is short enough. It's review. Like if I had a very, very lengthy handout, what review? I mean, chapter 1, chapter 2, you just go through handouts. And I very briefly, actually, I emphasize very briefly, define everything. So that's kind of, and also I want you to do your own review sheet because as you read, whatever it's important, write it down. Definitions based on problems. That's part of your self-study. The way that you study, create your own review sheet to review maybe night before or something. Any other question?
I have a
Yeah, go ahead.
on so in the homework we have like an independent source, but it's not given, so we just I don't think that circumstance was explained, or I don't know how to connect those dots.
What
Number 3.
Which problem?
Number 3 on the homework number 3.
Homework number 3. Which problem?
Number 3. So both. Homework number 3.
Oh, okay. In this case, find V.
Yeah. So since one of them is I was just trying to turn it into
Okay. What happens here? One voltage division. Okay. What you do is homework number 3. I explained this one here. Okay. What is voltage? First of all, you simplify 2 voltage sources. Use one of them as use V as your base. So it's V plus 24. That's your total source, right? Which part I didn't explain? Okay, you add 2 sources. You substitute by 1. One of them is unknown. The other one is given. You have 2 ohm, 10 ohm, 6 ohm, and 4 ohm. Okay, use voltage division. What is this voltage?
Thank you. I can connect the dots. As soon as you said that, I can turn that symbolically into V plus 24. I realized.
Yeah. So what you do is you get 4 divided by 4 plus 6 plus 10 plus 2, and it's equal to 8. You have one equation. When I know you solve it for me.
Thank you so much, Professor.
Okay, no problem. By the way, problem number 4 is not delta, because some people, as soon as they see number 4, they think it's delta Y. It's not delta Y. Those of you who are listening, still listening. Number 4, that's a trick. That's actually a problem that you see a lot in EIT exam. And it's not delta Y. Because 4 and 8 are in series, combination in parallel with 4, combination in parallel with 3, combination in parallel with 3. I mean, as soon as people see something with angle, they think it's delta Y. It's not. This is actually regular case. Okay, you can ask all these questions on Thursday, as I said. Just try to do the problem. Oh, I went way over. Okay, thank you. Have a good day. Thank you.